Hello and welcome to my debrief of the March 2026 mock exam. In this video we're going to look at the 15 Section A questions, which are worth 30 marks, that's 2 marks each. We work on allowing about 1.8 minutes per mark, so that's about 54 minutes that we allow for Section A. Before you watch this debrief video, I'd recommend attempting the mock yourself, because by practicing that gives you the best outcome, and then use this debrief to see the areas where perhaps you struggled. If the mock has gone from the platform by the time you're watching this, you could always pause the video at each question, attempt each question yourself, and then watch the debrief after. I'm not going to read each question out in the interest of time, so what I'd recommend is as I get to a question, if you pause your video, you can then read the question off the screen, and that will prevent having a very long video. So this is the high-low method. We use the high-low method to first eliminate the fixed costs so we can work out the variable cost per unit, and then we use that to work out the fixed costs. In this question, we've got this additional part that there's an additional fixed cost if they go over 50% capacity. Well, capacity is 60,000, so that means there's an additional fixed cost when there's 30,000 machine hours or more used. In the scratch pad here, I'm just going to capture the high and low. So we use the independent variable to decide what the high and low is, and machine hours is the independent variable. So we're going to use Q4 and compare to Q2. So the difference in machine hours is 30,000. But before I work out the difference in conversion costs, I'm just going to do that adjustment for the 60,000 because this line includes this additional 60,000. So now we've eliminated all of those fixed costs, including that 60,000, leaving us with 2.1 million divided by 30,000. You see I'm not typing all the zeros in, trying to save a bit of time. Means our variable costs are 70 per machine hour. Then we need to use that 70 to work out the fixed costs. I'm going to use Q2. Often it doesn't matter whether you use the high or low, but because of this 60,000, it's going to be more efficient if I use the Q2 calculation. You wouldn't need to write this out, but the total cost equals the fixed costs plus the variable cost per hour, machine hour that is, multiplied by the number of hours. Our total cost is 925. We're trying to find the fixed costs. The variable cost per machine hour is the 70 we just worked out, multiplied by the 12,000. But I'll make it 12 just to get rid of the zeros. This is giving my fixed cost as 85,000. And then using the same formula we've got here, so our fixed costs now at 85,000, but we're looking at 35,000 hours, which is incurring this extra 60,000. So now our total is 2.595 million. So looking at this question, the correct answer is average room occupancy rate. That is a measure of resource utilization. Guest ratings, that's not resource utilization, that's a customer focused measure. And the rate, the amount they're charged per room, isn't about how they're using their resources. On to question 3. If you've seen any of my debriefs before, you'll have seen why I use the scratch pad in this order, in reverse order. And in case you haven't, if you were to go in the process where you add your questions further down, you see I've written test here. This is at the bottom, and I close that. And when I come to open it again, the test is at the bottom. So I have to scroll down. As this gets longer and longer, I'm wasting more time scrolling down. As it always opens at the top, I put the most recent question, the one I'm working on, at the top, and then that keeps the order. It is in reverse order, but at least I know where to find things. So we need to find the relevant cost of each of these components and select it from the table. Looking at component X first, the original purchase cost is a sunk cost. That's not a future cost. The resale value is not relevant here because, as it says, the component is in use, so the relevant cost is the 6,200, which gives us option 1 and 2. With component Y, once again, the original cost is irrelevant. They've got some in inventory, but it's not commonly used, so therefore their current position is to have to dispose of this, which is why it's telling us there's an allergic issue. So it's going to cost them $2,000 if they do nothing. So if they now use that, they've saved $2,000, and the rest will be purchased at $5,600. So the actual cost is $3,600 because it's the $2,000 saved and the $5,600 they need to spend. So the correct option is option 1. I thought I was going to have to do a work-in, which is why I opened up the scratch pad, but I didn't need to in the end. In question 4, we need to use the 3 E's of value for money to decide which each of these are. The patient to doctor ratio, that's a measure of efficiency. Although it hasn't got the word per, it is patients per doctor. Per is often the giveaway for a measure of efficiency. And readmission, if patients are readmitted, it means treatment wasn't successful, so that's a measure of effectiveness. This is just a technical knowledge question from the syllabus. The information system that ties all of these together is an ERPS. Transaction processing systems, normally used at the operational level, executive information system at the strategic level, and a CRM is around how we manage our relationship with our customers and our potential customers. There's quite a lot going on in this question. Question 6, we need to use throughput accounting. We need to go through the stages of that to work out the ranking of each of these in terms of the throughput accounting ratio. And then we need to decide on how much to produce of each, and there's this minimum order of 6,000. Because that's the minimum order, we can eliminate option 3 at the outset because the 5,600 is lower. If I was to be honest, if I was doing this question, I'd probably flag this one and only come back to it if I've got time. But I would take a guess, and I would guess 2 or 4, just because the way these questions tend to be, the one that has the minimum order tends to be ranked lower. Once we've done the throughput accounting ratio, that's not always the case, but rather than leave it blank, I would guess option 2 or 4. Then I'd go through the rest of section A and then come back if I've got time. The way I would work is I would make myself a little table in the scratch pad here. The scratch pad is a bit clunky, and that's why it's worth practicing using it. You see, I've tried to line my columns up here. And the first step I need to calculate is the contribution, the throughput accounting contribution. With throughput accounting, we only take materials into account. So it's 55 minus 15, 41 minus 13, and 62 minus 24. And now you see I've put in the machine hours that each uses, because machine hours is where we are constrained. So now I need the throughput accounting contribution per machine hour, which is 40 divided by 4, 28 divided by 2, and 38 divided by 5. And so now we've got our ranking 213. If L is ranked 1 and we want to make 8,000, we've already made 6,000 of this. If we're now going to make 8,000, then we're probably now restricting it to the top 2 options. So if you'd got this far, I would guess option 2 based on what I said earlier. We've got 80,000 hours available. If we're going to make the first 6,000 of M, and that takes 5 hours, that uses 30,000. So that leaves me with 50,000. Next, as ranked 1, we would make 8,000 of L, which uses 2 hours. So that's another 16,000. So I've now got 34,000 hours left. Rank 2 is J. This uses 36,000. So we can't make all of the J. I can quickly see that is it going to be about 8,500. And if you wanted to do the calculation, there it is. But if you can avoid doing a calculation, because we'd already narrowed it down to option 1 or 2, it was clearly going to be able to make more than 1,000. So we got to option 2 a bit more quickly. This is an optimum pricing question. We are given the demand curve formally on the formula sheet. And B and A, they're constants. P and Q are variables. So B is calculated by the change in price divided by the change in the number of units, which is 10 over 20. So we've got a value of B. We need to find A, but we've got a value of P and the corresponding value of Q, which is this 200 for P and 1,000 for Q. So when we put all of those into P equals A minus BQ, we end up with this. So therefore A is 700. And once we've got A and B, we can now write out the demand curve for this specific product. And this means if we know a value of P, we can find the value of Q and vice versa. In terms of maximizing profit, we use the other formula next, which is this one, MR equals A minus 2BQ. This is the marginal revenue. The marginal revenue is the same as the marginal cost at that optimum point. The marginal cost is the 140 per unit, but the constants A and B are what we've just worked out. So that's the marginal cost of 140 equals A, which is 700, minus 2 lots of B multiplied by Q. When we rearrange that, we end up that Q is 560. And now we need to take this value of Q and put back into here to find the corresponding value of P to find the price. When we do that, we end up with P is 420. These optimum pricing calculations are often quite lengthy because there are several stages, and it's worth trying to practice those stages. The challenge here is you only make one mistake and you've got the whole thing wrong. So obviously there's an additional challenge there compared to where we've got 4 to select from. Looking at detection costs, we're told there are 2. Monitoring pollution levels, that's detection. Power usage measuring, that's also detection. What is useful is also making sure you can allocate each of these others under this same classification. This is the one that has environmental prevention costs, environmental detection costs, as asked here, environmental internal failure costs, and environmental external failure costs. Water purification, the failure has already occurred because the water is impure, but because it doesn't get to the outside, that counts as an internal failure cost. The carbon filters, they are preventing that emission, so that's a prevention cost. Payment of fines, that would be an external failure cost. Insulating pipes, that prevents heat loss, that's a prevention cost. PR, that's an external failure cost. And capturing and recycling of waste exhaust gas, well, the waste exhaust gas has occurred, so that's a failure cost, but it doesn't go to the outside world. So that's an internal failure cost. In this calculation, we need to find out, is the variance adverse or favourable, and is it either 800 or 900? Once again, I'm going to create a little table in my Scratchpad. When we're looking at a mixed variance, we're comparing the actuals, which I call the actual quantity at the actual ratio. Sometimes you see it as actual quantity in the actual mix. And we compare that to what would it look like if we used that same volume of paint, but the mix was in the standard ratio, as given here, and the comparison between those, and because there's a different cost for each, some will be favourable, some will be adverse, and then we'll work out a total adverse or favourable variance. So the actual is what we actually used, and we need to total those together because then we take that total across to the actual quantity, and what we now do is take this actual quantity of 6,000 and then we reallocate that 6,000 litres based on this standard ratio. 30 plus 50 plus 20 adds up to 100, so we've got a nice easy number to work with, which means in our standard ratio, 30% or 30 hundredths would be R, 50% or 50 hundredths would be S, and 20% would be T. So you see, I'm just doing those calculations now, and then we need the difference between each of those. Make sure you use the standard cost, not the actual cost, because we're just looking at the impact of the mix. We're not looking at the impact of the amount they paid per litre. And then I multiply the standard cost by the difference. Now I prefer to not do my adverse and favourable until I get to this point. And here, because our actual used more than our standard, that would be an adverse because we're talking about a usage. Here our actual used less than our standard, so that would be favourable. And here our actual used more, so that would be adverse. So I can see it's an adverse variance. I've got 10,800 adverse, 10,000 favourable, so that leads to 800 adverse. Target costing, we set the selling price based on the market. It's not based on the costs, so that is not a feature of target costing, but we do all of these other things when we are using target costing. So on this activity-based costing, obviously we're looking at packaging and dispatching costs. We know the total is 10 million, but what we don't know yet is how many orders there are in total. So that's our first step. With Charlie, we've got 5 million is the volume. We have 2.5 units per order. So there's 2 million orders of Charlie, and Tango is 6 million divided by 2. So there's 3 million orders of Tango. So we've got 5 million orders for these two, but we have 20 million orders on other items. So now we've got 10 million in costs across 25 million orders, which is 40 cents per order. That's one of our answers, but just check we're answering the question. We want the packing and dispatching cost per unit. We've got per order. An order has 2.5 units, which is 16 cents. Question 12 is looking for two controls. Because they've got physical hard copies and because the consultants are working in different areas with commercially sensitive information, and in addition, they use non-networked computers, the spyware and the firewall aren't going to be relevant here. The lockable cabinet or safe for the physical hard copies, and obviously confidentiality contract because we need to contractually oblige them. Okay, on to question 13. We're looking for the third quarter of 20XT7. We've got the trend line. X is the quarter number. And if the first quarter of 20XT5 was 13, the third quarter of 20XT7 is when X is 23. So using the trend alone we end up with 2,575. I'm surprised that wasn't one of the distractors. It normally is. We now need to do the seasonal variation. So the third quarter is 4%. So we multiply that by 1.04. Gives us 2678. So taking a look here, we can eliminate this bottom one because it isn't a one-off project, it's a repeated project. And the expected value, if you're using the expected value, you would choose the highest expected value, which is 275. So that means you would choose the bus station, and expected value is linked to risk neutral decision making. So the answer is the top one. Options 2 and 3 are a little bit strange, I think, in this question because we don't have information to be able to work out if someone is risk averse or risk seeking. So by elimination, we end up only being able to choose the top one here. And then our final bit of section A is a break-even analysis. And we have a scenario where for every one console they sell 9 games. And we need to work out how many consoles they sell. So we need to, the term I use is basket this up. So we need to create a basket of 1 console to 9 games, work out how many of those they need to sell in order to break even, and then separate that basket out to work out how many consoles. So this basket I just mentioned, we work out the contribution. And so in the basket, which has the 10 items, there's 1 console, which is 200 it sells for with costs of 50. So our contribution is 150. And then for the computer games, they sell for 60 with a cost of 10. So that's 50, but there are 9 in a basket. So the contribution for a whole basket is 600. Our break-even point is 1.5 million. 1 basket gives us 600. So that means we need to sell 2,500 baskets in order to break even. And now we break down our basket. If we're selling 2,500 baskets and there's 1 console in a basket, then we need to sell 2,500 consoles. So thanks for listening to this section A debrief of this mock. There'll be separate videos for section B and section C. Thanks very much.